So manipulation of the independent variable, the most usual way is to have a treatment group and a control group. Yeah, and then you introduce a change to the treatment group, but not the control group. Used in psychology a lot, and in finance, in my field, we use it to understand how individuals and market behave in different contexts relative to finance. So there's a website there which gives a whole lot of examples, experimental finance.org, and you'll see all the different ways that experiments are used in my field. So an example, a paper by colleagues of mine, Heaney et al., and they looked at whether two heads are better than one. Yeah. So they got novice, beginning share traders, and they looked at teams of two people, trading, or one person trading. Yeah. So they had 54 students. Yeah. So 34 of them, they put in a two-person team. So they had 17 two-person teams. Yeah. And that's, of course, that's 34 people. So 17 times 2. And they also had individual traders. So that was 54 students in total. 34 were in the two-person team. So that left 20 individual traders. So they looked at what are the outcomes of individual traders versus the outcomes of a two-person team to see whether two heads are better than one. That's good. That's not a bad introductory paper to look at, right? How you measure the changes in the independent variable, the two-person versus the one person. So that was the independent variable. So you can also have more than one thing you're changing, right? You can have experimental design with more than one independent variable. Yeah, and that way you can have an effect of one independent variable and the effect of the other independent variable, and then you also get an interaction effect. An interaction. So here's an example. People worried that children who watch violent cartoons, right, that might increase their aggressive behavior. Yeah. So some people worry that if children watch violent cartoons, that's going to increase their aggressive behavior. But other people say, well, I don't think that makes any difference. Children are smart enough to know that's just, make believe, and it doesn't affect their behavior. What's really important is whether children suffer from frustration or not. Yeah. So what if children are frustrated, by their, by their health condition, by where their surroundings, by the family situation, the children are frustrated, then that makes them very aggressive, right? So in this test design, we're going to have, violent students watching violent, children watching violent cartoons, and non-violent cartoons, and we're going to have children that are frustrated and children that are not frustrated, right? So we're going to have the effects of violent versus non-violent. Yeah, we're going to have the effects of frustrated versus not frustrated, and as well, we're going to have the interaction effects. So we're going to have the main effects, which are the effects of each factor. We're going to have the interaction. What's the influence of one factor on the dependent variable at different levels of the other factor, and we're going to have simple effects, that is the effect of one factor within a level of another factor. So main effects, interactions, simple effects. And these are all of the various comparisons. So you need to be ensure that the manipulation of the manipulation of the independent variable that is causing the changes in the dependent variable, right? So to do that, you've got to have control over all extraneous variables. So things like situation and participant variables, history effects, maturation effects, prior testing, experiment effects, demand effects. So the use of a placebo effect is important here. So a very famous experiment, is the Hawthorne effect. So this is a very famous effect. So this experiment took place in Hawthorne, which is a suburb of Chicago, and it took place at Western Electric's factory. So what is the effect of physical conditions on productivity? So the way the experiment worked, they split the workers into two groups. And for one group, they improved the lighting dramatically, and the other ones remained unchanged. However, did that make a difference? Well, it did, right? But it actually made a difference for all the groups, right? The employees' working conditions were changed in other ways, their hours, rest breaks, and in all cases, the productivity improved when a change was made. And by the time everything returned to what it was, productivity was at its highest level, and absenteeism, that is not going to work, had plummeted. So it turned out that the experimental factors actually had little impact on the productivity. So there was a big experimenter effect. You were affecting, people conducting the experiment were affecting the outcome, right? That someone was actually concerned about the workplace, that's when they saw that people were actually interested in their condition, that encouraged them to work harder and increase their productivity. So the experimenter themselves had a big effect here, right? So this is why you've got to be very careful to account for extraneous effects. The other thing you can do is you don't just run one experiment, right? You just don't have one group of students in, say, a two-person team versus students in a one-person team. You don't just have one, you do that every week. You might do that every day or every week. So you get a whole lot of different experiments, right, doing the same thing. And, that in case there's any error in any one, you can average effect across all of these experiments. So this is a good way to reduce experimental error. The replications reduce experimental error and ensure that your the point estimates for the unknown parameters give a more reliable test of your hypothesis. So randomization, where going back, just recapping, the subjects are not identical. We know the subjects aren't identical, not even in matched pairs. So you can allocate them in random order, and responses should be measured in random order if possible, and that helps protect against extraneous factors that are unknown to the experimenter. The randomization helps if you can do it.
Okay.
Internal validity is very important.
Right? Sorry, Tom. Excuse me. Yep. Could you rewind maybe 2 slides? Yep. That's possible. Yeah, and slow down a little bit.
So replication talks about where you do the experiment more than once. So you might do the experiment where you have a 2-person team versus just individuals. See whether 2 traders are better than 1. But that's going to have experimental error, right? So you might then want to do it again, have another group of students where they into 2-person teams versus 1-person team, and then you do it again and again. So you have a large number of experiments which you can average over, right, to get a good idea of the effect of the 2-person team versus the individual traders on the result, right, the trading outcome. So we know that subjects aren't identical, right, even not in matched pairs. So, sometimes it's best with the matched pairs, we think we've got all of the extraneous factors covered, but we might not, right? So that they're random order, you put them in the treatment and control randomly, then that is going to help. That is going to help you to account for extraneous factors. So random assignment to one group, the control group versus the treatment group, is going to help a lot with controlling for the extraneous factors. And this is essentially what we're talking about, is holding all else constant. Yeah? Holding all else constant. So now we move on to an internal validity, right? And that is the ability of the experiment to answer the question, whether the treatment was the sole cause of the change in the dependent variables. Right? So
sorry,
was
Tom, are you moving to the next slide?
drug that you gave the patients, was that the reason that they improved? So that's what internal validity is talking about, right? So did the treatment do what it was supposed to do? So you can, internal validity is why you have the control group. Yeah, that's why you have a treatment and control group, why you have random assignment, and why you do pre and post testing. Yeah? So internal validity is, are you confident, right? Can you show someone that was the change, that was the treatment that caused the change in the dependent variable? External validity is talking about whether the experimental results can be generalized.
Sorry, Tom, excuse me. Are you moving the slide?
Yep.
We are seeing control over extraneous variables.
It's moving here for me.
Are we supposed to have moved on 1 or 2 slides?
So we're on to internal validity.
We're not seeing that.
Oh, okay. So it's here for me.
Maybe take some refreshing.
Where are you now?
Control over extraneous variables.